Hello everyone. In this video, I will discuss homework 7 and homework 8. So let's begin the discussion. In the homework 7, we have this problem 43, 42, 43, 23, 24. These problems. So let's look at the problems. So this maths actually will match with this 22, 24 and 42, 43, 40, 46. These are the math number. And 23, 24 number math, these two will match with 23, 24 number math is these two math actually. Okay, so let's discuss the solution. You see, 23 number math. See, we have to find out domain, range, intercepts, etc. etc. So for this math, domain will be what? This math. See, we have just only one asymptote at x equals to plus 2. That means domain will be, this is the vertical asymptote, right? So domain will be all real number other than plus 2. That's why I said it here. All real number other than plus 2. And this one, range will be, see, range is at y equal to 1. So range will be all real number other than, range is all real number other than plus 1. Other than plus 1. So y is not equal to 1 means all real number other than, this means y is not 1. So range is actually all the real number other than plus 1, positive 1. Then intercepts. Intercepts of this question is just only here, okay? Just only this is the intercept, 0, 0. This is the intercept. Then horizontal asymptote. Horizontal asymptote is just only this line, y equal to, let me make it bigger. Let me make it bigger. And bigger is better, okay. Horizontal asymptote for this question is y equal to 1. This line, y equal to, this line's name is y equal to 1. Suppose if I draw a line here at 4, this will be y equal to 4, horizontal line, okay. Then vertical line. This is the vertical line, right? This is the vertical. And where is it? This is at 2, plus 2. So this vertical asymptote is x equal to plus 2, okay. So vertical asymptote is at x equals to plus 2. Domain is 2, range is 1, x intercept y intercept, horizontal asymptote 1, vertical asymptote x equals to 0, oblique asymptote none. 23 number, vertical asymptote x equals to 0. Hey, this is wrong actually. This will be vertical asymptote x equals to plus 2. Okay, let me check 23 number. Yes, x equal to plus 2. It will be from the book also. I can see. I mean, I'm just making sure that this is exactly the question. So yeah, this will be plus 2 and oblique asymptote none. And you can see there is no oblique asymptote. And from the concept also we know that there will not be any oblique asymptote, because if there is any horizontal asymptote, then there is no oblique asymptote. Okay, then we have 26 number. This is 24 number from your book. 24 number is this method. So let's look at this. What is the domain? So see, now I think you have got some idea. Domain will be, see, only we have one vertical asymptote. That means all real number other than minus 1. This minus 1. Domain is all real number other than this minus 1. This line. This line is the forbidden line. Here the graph cannot come on this line. Graph is going forever in the negative side and then coming closer to this line. Graph is going forever in the positive side and coming closer to this line, but it will not cross this line. That's why all the numbers are possible other than this line, this number. That's why domain is all real number other than minus 1 or except minus 1. Range. Now see, you can say, okay, then sir, maybe the range is all real number other than y equal to 0. Which you can say, but there is no graph here. See, in the downside it is empty. That's why we cannot say it anymore. We have to say range is all the positive real numbers. Or we can say y is greater than 0. Greater than 0 means the positive side of the y line. And 0 is not included. We have to say y is more than 0. Y is greater than 0. Y is greater than 0, we have to say. What is the x-intercept? There is no x-intercept in this graph. What is the y-intercept? Y-intercept is this one, 0, 2. This is the y-intercept. Then what is the horizontal asymptote? Horizontal asymptote is this one, which is called y equal to 0. What is the vertical asymptote? Vertical asymptote is this one, x equal to -1. This is the vertical asymptote. Okay, this is the vertical asymptote. Then we have got 42, 43. We have got some math here. 42, 43, 46, etc., etc. This math. 42, 43. So 42 is thrice x plus 5. Let me see if I have this math here. 42 is thrice x. Yeah, thrice x plus 4. Thrice x plus 5. Thrice x plus 5 divided by 6. So 42 is this math. 42 is this math means this is actually another addition, so I have to match it, match all the math. So 42 is this math, 42 is this math. Okay, from this math we have to find out vertical, horizontal, and etc., etc. So 40 here 42 means in here 44. Okay, so we have to find out the vertical asymptote. Vertical asymptote comes from here, right? So this is x equal to -6, so vertical asymptote will be x equal to 6. Because if I put here 6, function is undefined. Asymptote means find, this is, as vertical asymptote is actually the place where my function is undefined. That is the vertical asymptote, because there my graph cannot go. Okay, that's why. So vertical asymptote means that. Now horizontal asymptote, see, power of x is 1, power of x is 1. That means what? 1, 1. Same. If it is same, then the horizontal asymptote will be y equal to ratio of their coefficient, 3 divided by 1. 3 divided by 1 means 3. That's why horizontal asymptote is y equal to 3. Okay. And there will be no oblique asymptote, as you know. If there is horizontal asymptote, there is no oblique. If there is oblique, there is no horizontal. That's why. Okay, now 43 number. 43 number question is x square minus 8 divided by, yeah, this question. X cube minus 8 divided by this. Now, what will be the asymptote of this question? First of all, see, this is x square, this is x cube. So what type of horizontal or oblique? Which asymptote you will get from here? One more. That means oblique, oblique asymptote. And to get the oblique asymptote, we have to divide it by long division method. Okay. So if you divide it by long division method, after division you will see x plus 5 will be the answer after the division method. We have done the long division in many other places, so that's why we are just not doing it now. So oblique asymptote will be x plus 5, y equal to x plus 5. How come vertical asymptote is x equal to 3? Because if we do middle term factoring here and a cube minus b cube formula here, you will see x minus 2 and x minus 2 will be cancelled out from the numerator and denominator, and then x minus 3 term will be remaining here only. Middle term factoring, you can do middle term factoring here and a cube minus b cube formula here. Then in the second line, x minus 2 will be cancelled out. Only x plus 3 will be remaining. From that x plus 3, you will get this vertical asymptote at x equal to plus 3. Because it is minus 3, so vertical asymptote will be plus 3. Here this math. Then 46 number. 46 number math is 4x cube divided by, okay, where is my math? 4x cube 4x cube math. Yeah, this one. No. 4x cube. Maybe I don't have this math here. Or do I? Go for 46 number math. 46 number math is 46. 4x to the power 5 divided by x cube minus 1. 4x to the power 5. Do we have this kind of math here? No math of this type. 4x cube. I think you have the book. So let me tell you the solution here. Okay, solution from here. So 46 number math. Let me read the question. 46 number math is 4x to the power 5 divided by x cube minus 1. Okay. So you see 4x to the power 5. That means divided by x cube. That means power is 2 more in the upper side. So in the numerator, if power is 2 more, you know that then there will be no what? There will be no oblique or horizontal asymptote. So this conclusion comes from there. And vertical asymptote, how come vertical asymptote x equal to 1? Because you look, the denominator is x cube minus 1. So if it is x cube minus 1, then you see for the plus 1, x equal to plus 1, the function is undefined. That's why this is undefined at x equal to 1, x equal to plus 1. That's why it is the domain. It is the vertical asymptote. It is the vertical asymptote. X equal to 1. And domain actually, okay, if as I said, if anyone tell you to find out the domain from here, then the answer will be all the real number other than 46 number. This is not the question, I am just saying it. Domain of 46 number question will be all the real number other than x equal to plus 1. That will be the domain. Then let's go to the next one. This is, I think this math is optional. These are optional challenge problems, so if you have done it, just have a look. And then this one is from 4.3. so 4.3, we have to find out a couple of things from this. Let's maximize it. 4.3, this question. So from 4.3, this is homework number 8. In problem this and this, follow steps 1 to 8 on pages 196 to analyze the graph of each function. So this is the question: x square plus 5x plus 6 divided by x plus 3. This is the question, and this is another question, 38 and 37 and 38. Okay, and I said to solve 8 number question also from the book if you have time. So let's look at the solution now. Now this question, both of these two questions, 37 and 38, both of these two questions is very unique in nature, because this is the solution of the graph. Normally, why I'm saying it, normally our graph is like this, then maybe like this, in the rational function, like different type of graphs. But in this question, actually we have just got a straight line. Okay, why is that so? Why? The reason is, look, this is x square plus 5x plus 6 divided by x plus 3. So this x plus 3 is safe here. But if we do the middle term factoring, then we get x plus 2 and x plus 3. Then x plus 3 and x plus 3 is cancelled out. As these two terms are cancelled out, only remaining is x plus 2. Now see, as I said, if we cancel out any variable term, we have to give a condition, and this condition will be x cannot be equals to minus 3, because x plus 3 we cancel out. So x equal to minus 3 we cannot put here. Do you see? X equal to minus 3 we cannot put here. If we put x equal to minus 3, then the function is undefined. Now, although we have cancelled them out, but still we have to carry one condition. Our condition will be x, this is the condition, x cannot be equals to minus 3. And I'm just trying to type by mouse. Okay, x cannot be equals to minus 3. This is the reason why we have got a hole here at minus 3. See, minus 1, minus 2, minus 3. So there is a hole here. This is the hole. Okay, this hole came because of this cancellation. If you cancel out something, if you do this cancellation in the numerator and denominator, if you do it with some variable quantity, if you cancel out, you have to give that hole in the graph. Okay, now see, in fact, you can say, sir, all the graph you have drawn in the class or very like some other things comes here, some graph like that. Why this graph is just a line? Because due to this cancellation, our function became just like a line, x plus 2. Y equal to Rx means you can consider just simply this is y. Y equal to x plus 2. X plus 2, what is this? Y equal to x plus 2 is just a straight line. Okay, that's why, and this is the straight line. How can you draw y equal to x plus 2? How do we get this graph? So to get this graph, you have to draw like, okay, x here, then y here. So if think about some value of x, let's say x equal to 0, then y equal to what? X equal to 0, then y equal to what? Rx equal to x plus 2. That means it is just only 2. Then if you put some other number, see, this is the point. 0, 2 means this point, this point, this point. And then if you put, you can put minus 2 also. If you put minus 2, then if you put minus 2, the whole thing becomes 0. 0. That means minus 2 is here, minus 2 is here, and 0 is here. Okay, both is there. So then if you join these two lines, you get the line. Join these 2 points, then you get the line. And then you give a hole here at minus 3. You can just go there minus 3 and just towards the line you have to go, and you cannot give the hole here because hole will be on the asymptote. Hole will be on the asymptote. That's why this graph is very unique. Technically this x plus 2 is also our asymptote line also. Eh? Because if you divide x square plus 5x plus 6 divided by x plus 3, if you do this division math, you will see x plus 2 will come in the answer. That means this is our particle, this is our oblique asymptote also, x plus 2. This is our oblique asymptote also. So this math is very exceptional and unique kind of maths where there is no curve here. Normally in the rational function there are tons and tons of graphs, okay? But here why there is no graph? Because after the cancellation the function became linear. Do you see the reason? The function became linear. That's why we just have a line, nothing else. If you draw it, we have nothing to draw. Do you understand? We have nothing to draw. We have just only x plus 2 to draw. And this whole came because of the cancellation. So still, if anyone asks you, okay, then what is the domain of this graph? What is the vertical asymptote of this graph? Vertical asymptote, nothing. As you can see, domain of this graph is all the real number other than minus 3, because if you put minus 3 here, the function becomes undefined. So domain is that. Vertical asymptote, nothing, because there is nothing down here in the denominator, nothing here after the cancellation. So there is no vertical asymptote for this math. Horizontal asymptote, there is no horizontal asymptote for this math because the power is more in the upside, power is less in the downside. That's why there will be no horizontal asymptote. Then oblique asymptote, this is the oblique asymptote. How do we know that? After division, power is 2, power is 1, so just only one more. That means there will be some oblique asymptote. This is the oblique asymptote, etc, etc. What is the x-intercept? What is the y-intercept? So x-intercept will be, so if we put y equal to 0, this equal to 0, so 2 x-intercept comes, one is 1 x-intercept comes, one is our this value, this value. See, if I put 0 here, this side, this 0 this side, then x equal to minus 2 comes, which is this. This is the x-intercept. And y-intercept is what? If you put everywhere 0, here 0, here 0, here 0, just only this, x value 0, only x. Then 6 divided by 3, 6 divided by 3 means 2. This is the 2, this is the y-intercept, this is the x-intercept. So this is how we get the x-intercept, y-intercept, and etc, etc. This is the graph actually. So the final graph is like this, okay? Then this 38 number and 37 number is exactly similar kind of maths, so let's not, just this is the graph, let's not pass too much time on it. Then we have like technically blah blah blah, so you can see technically y equal to x plus 2 and y equal to x minus 2 is also oblique asymptote that intersects the graphs at every point in their domains. It is the hidden meaning why the graph is like this and what's going on in this rational function, okay, how it is related with this linear function. This explains the inner mechanism. This is challenge problem, but I will discuss little bit question number 8 also. See, because question number 8 has some nice solution that we worked on. See, question number 8 is I said this is to practice. I just have sent in the Google Classroom announcement to practice this question. Rx equal to x divided by x minus 1 into x plus 2. So see, this question, what is the maximum power? Upper side or downside? Downside, right? This is x minus 1, this is x square, x and x, that means x square, x square. So so the horizontal asymptote will be what? Horizontal asymptote will be what? Y equal to 0, right? Y equal to 0 is the horizontal asymptote. Then y equal to 0. Then let's talk about the domain first, because let's talk about the domain first. So domain will be, see, for what value of x this function becomes undefined? For x equal to plus 1 and for x equal to minus 2, this function becomes undefined. So domain will be all real number other than plus 1 and minus 2. This is the domain. And horizontal asymptote, I already said y equal to 0 because maximum power is downside. As there is horizontal asymptote, so there will be no oblique asymptote. What will be the vertical asymptote? So vertical asymptote, there are two vertical asymptote in this question. One is at x equal to plus 1, another one is at x equals to minus 2. So two vertical asymptote we have got from here. Then we can find out like what will happen, and look, this x intercepts So can we find out the x-intercepts here? What will be the x-intercept here? If we put this equal to 0, this equal to 0, then we get the x-intercept, and x-intercept will be x equal to 0. Okay, because this x minus 1 and x plus 2 will be cancelled out, so x equal to 0. What will be the y-intercept? So if we put 0, 0, 0 in every x, then everything becomes 0. This is an answer. Okay, 0 divided by whatever it is, this equal to 0. That's why y-intercept is also 0. Let me show you the solution of that question. Solution of this question, I was looking at this. I have the graph here. This is the solution of that graph. Okay, this is the solution of this graph. So look at the graph. So look at the solution. This is one asymptote at x equals to minus 2. Then another asymptote at x equals to plus 1. Then we have another asymptote. This is the asymptote y equal to 0. Then you see here we have the intercept, and in this intercept our graph crosses. And why our graph crosses here? The reason is, if you look, the reason is power is 1. Okay, this power is 1. The power is at the intercept, power is 1. So we have this, or you can just look at the behavior also. Behavior at each x-intercept. If we put 0, then what happens? Okay, this will give us some more sense how it comes at each x-intercept, because at each x-intercept we can test it that way. We have this test for the value. Anyway, so this is the graph. So in this graph we get the regular in this graph we get some regular rational function kind. Why I'm showing you this one? Because our previous graph, this graph is a little bit like just a line. So this one is more like a regular rational function kind of graph. There are many parts, asymptotes, vertical, horizontal. There are many different parts. Everywhere there will be arrow sign. That's true, as you know. See, this is the, if I unzoom, so, and then they have some asymptote thing. So if I just go down, you will see graph is coming closer and closer and closer to the line. Is not coming view larger. If I give view larger, what happens? This is what happens. So this is the thing. Okay. All right. I think you have got some sense about the graph and how to do it. I'm just using symbol app. I'm using this one. There are some other graphing calculator also. All right. Thank you all. Thank you very much. I think these are the discussions. Let me show you very quickly about the challenge problem also, so that you can have a look about the challenge problem also here. So this graph you have seen shows challenge problem. This is one challenge problem. This is another one. If you can do, this is another challenge problem. All right. I hope you enjoyed, or it helps a bit. Thank you all. Thank you very much. Bye bye.